Hey YouTube, this is Zane. I'm making another video tonight. I just got out of a really great tutoring session with a student who was learning to graph quadratic functions, and I thought this would be a perfect topic for a short video tonight. So I've got a simple quadratic up here on my slide, and let's say I want to graph this on just a standard XY plane. Now a lot of you might be wondering, how in the world am I going to graph something like this when I've got x squareds in there, I've got an x in there, and I've got just a plain number? I mean, at least with y equals mx plus b, it gave you a pretty big clue as to what the slope was, where the y-intercept was. But this format right here doesn't really tell us much right off the bat. So let's put little pieces together of this graph. Okay. So on a graph, wherever a graph hits the x-axis, that's called the x-intercept, and we can use x-intercepts to find out information about what the graph's going to look like. Okay, so to find the x-intercepts of a simple quadratic, the first thing you need to do is put it into factored form. Okay, so factored form is going to look something like this. Okay, so we know we're going to have to end up with something like this, but we don't really know what numbers are going to go here and here yet. So in order to factor something, we need to take a look at these coefficients up here. Okay, we need to find two numbers, these two right here, that are going to add to be this number, and that have to be times to be this number. Okay, so if we start thinking about combinations that add to -3, but times to be -4, only one combination should work. Okay, so if you want to pause the video right now to stew over that and see if you can find the answer, go ahead and do that right now. Okay, but I'm going to tell you right now, just for the sake of time. So the only combination that adds to -3 but times is to be -4 is -4 and +1. Okay, work that out in your brain just to make sure that I'm right. So now that I'm in factored form, I could set this whole equation equal to 0 to figure out where my x-intercepts are going to be. Okay, so right now I'm going to draw my little graph. Okay, so in order to make this factored form equal to 0, we got to find out what we can plug in for each of these x's to make this whole thing to 0. Well, it turns out the things that we can plug in are going to be the opposites of these numbers. So what's the opposite of -4? +4. So one of our x-intercepts is found at x equals +4, which is right here on our graph. Okay, let's go to the other factor now. We've got x plus 1. So let's take the opposite of +1, and we get -1. We know our other x-intercept is going to be right there. Now, we've got where our parabola is going to cross the x-axis, but remember, parabolas also have a vertex, or in other words, a peak to them or a trough to them. So we're talking about the minimum or the maximum point on the parabola. Okay, we need to figure that out to be able to complete this drawing. Okay, so I'm going to show you a little simple formula to figure out the coordinates of the vertex. Okay, first things first, x coordinate of the vertex, you can find that out by using this little expression. It's equal to -b over 2a. So if you're used to dealing in quadratics, we usually identify the coefficients up here as a, b, and c. Okay, so a is equal to 1, b is equal to -3, and c is equal to -4. Okay, so if I'm using this nifty little formula, I'm plugging in -b, which is -3, over 2 times a, so 2 times 1. Well, -3 is the same thing as a +3. 2 times 1 is just 2. Okay, the x-coordinate of my vertex is found at 3/2, or 1.5. Okay, so right here, I don't really know the y-coordinate yet, but if I want to go over to my graph, I know that my x-coordinate is about 1.5. So my vertex is going to lie somewhere along this dotted line. So let's figure out where that somewhere is. Okay, so to figure out where that is, we're going to take our x-coordinate we just found, we're going to plug it into the original expression up here. So I'm going to take 3/2 squared minus 3 times 3/2 minus 4. Okay? When I simplify that, I'm going to get 9/4 minus 9/2 minus 4. Okay? Let's do some fraction simplifications. Okay, well, if we want to make all these a common denominator, then the least common multiple of all the denominators is 4. Okay, so 9/4 is okay where it's at, because it's already 4. But we're going to make 9/2 equal to negative 18/4. And negative 4/1 is the same thing as negative 16/4. Okay. So we're taking 9/4 minus 18/4 minus 16/4. Okay, well 9 minus 18 is just the same thing as negative 9. Negative 9 minus 16 is negative 25. And our denominator stays the same as 4. So this is our y coordinate. Okay, so negative 25/4, that's going to be about negative 6 1/4. Okay? So now we can go over to our graph and count down 1, 2, 3, 4, 5, 6 1/4. Go over to our x coordinate, which was 3/2. That's where our vertex is. Okay? So it's going to be right there. So now we can connect our dots and form a nice parabola. I'm not the best artist, so my parabola looks a little weak. But that is how you graph a parabola. You find the x-intercepts by factoring if you can, and then you use this formula, negative b over 2a, to figure out the x-coordinate of your vertex. Okay, so this is x-intercept, this is x-intercept, this is your vertex. Okay, it's that simple. Once you've got those three things, you can draw your parabola. Hopefully this helped. I'm going to see if I can come up with some more complex examples to show you in later videos, because believe it or not, sometimes you run into examples where you can't factor, and so you can't really find x-intercepts if you can't factor. So there are multiple ways to draw quadratics. This is just kind of the most basic. If you have questions, feel free to send me a message. Otherwise, stay tuned for our next video on something a little bit trickier. Thanks for watching. Hope to hear from you guys soon.